Good morning, everyone. So I am Andrew Joseph. Thank you so much for having me here. And yes, I am having the wrong view. Wow. Okay. Okay. Uh, we'll work with that. Okay. I'm sorry. Oh. Okay. Oh, this. Oh, thank you for that. Okay. Okay, again. I'm Andrew Joseph. I work for Intel, and I do a lot of work in Android space. A quick raise of hands for people who have already worked in Android. Anybody who has worked on Android? Okay. Oh, nice. Okay. So, how many of you have actually done some dynamic analysis on Android? Dynamic analysis. Okay. And what have you used for doing the dynamic analysis? Anybody from the audience? What tools have you used to do dynamic analysis in Android? Sorry? I'm sorry? Okay. Yeah, sure. So the state of dynamic analysis on Android is kind of sad because you have to write your own hooking code in C++, make it into a library, inject into the process. Hopefully it works. If it doesn't, open up your IDE again, write the code, do the whole process again, make sure it works. And it's super complex. Considering, yeah, sorry? Can somebody give him a mic, please? It's audible.
Excuse me.
Yeah.
You just said that there is no real solution, but I heard about something called QQ Sandbox and then
Cuckoo Sandbox,
Droid.
right? Yeah.
QQ.
So I will explain how it works. Basically, there is this component that you install on your phone for the Cuckoo Sandbox, and then you run your app, and it hooks specific modules which Cuckoo Sandbox has already written code for. It uses something called as the Exposed framework, and that requires you to use a modified version of Android. Basically, you have to install the Exposed framework, but it is given as a package if you download the Cuckoo Sandbox. So that's what actually is happening. So if you want to do something extra that the Cuckoo Sandbox is not doing, what are you left with? So we are trying to solve this problem of dynamic analysis in Android by using a software called Frida. Anyone heard of Frida? Oh, yes. Okay. So it's about injecting JavaScript into a process and dynamically instrumenting it real time without you having to write any C++ code, compiling it into a library, and you don't have to restart your phone 1,000 different times like you have to do with the popular instrumentation framework. So the popular instrumentation framework in Android is right now Exposed framework. Have anyone used Exposed framework? Oh, yes. So you should know how many times you should restart your phone to just get a thing working. And it's mostly the security analysis person looking at the boot screen of Android most of the time. So it's really sad. So I will give you a short demo on how Android Exposed works, and then we'll look at how we can solve it. Okay, so this is a Genymotion emulator. And over here, we have the Exposed installer. So this is your first step of installing Exposed on your device. You go here, and it treats you with a warning. So if you're doing this on your daily driver, you should reconsider because your phone might not reboot properly. Okay, so that's very welcoming. Well, we will ignore. And I have already installed it, else you should click install and then do a reboot. So that's reboot number 1. And then you go to the modules, which I have already some pre-installed. And you click on whatever module that you want to select. So you click on this, and then again you have to restart. So for me, it's much easier, like, I'll just close this and I'll start it again. But if you have a physical phone, it's tricky. So I will do that now. Okay. Okay, I have the emulator here. I'll drag it down there. So yes, we'll all stare at the Android logo for a while. And while this happens, I will tell you how Xposed works. So Xposed installs a jar, which is the Xposed bridge, by modifying the app_process, which is the Zygote in Android. And basically, the modified app_process helps inject the jar file, which is the Xposed bridge, into every process so that you can instrument it. Now, let's go here. Response installer. Okay. Yes, it is enabled, so let's see if it works. Okay. So this is my phone's IMEI number. Right now, it's an emulator, so it just shows up this number. I can just change it to whatever I want. Like, 7 is there. Let's change it to 9. Apply. Okay, so I have to reboot again. Okay. Okay. And yeah, let's wait for it to come up again. And hopefully, when the emulator shows up again, your IMEI number should be changed. So it works by hooking the particular Java module, the Java class, which is responsible for returning the IMEI of your device. Okay, let's go here. Where is that app? Okay. Yes, it's now to this 9. So this is how the Xposed module works. With a couple of restarts, yes. And what if you want? What if there is no module available to, change it? So you have to write code, and you have to write code in Java, and you have to, compile it. You have to push it into the device, make sure it works, else restart again, compile the code again. So it's a big feedback loop. And let's see how we can solve it. So this is the tool that I have written, which internally uses Frida. And here, what you need to do is you just give the package name of the application that you want to instrument. And I will just bring up the emulator here. Okay. So this is our Android emulator, and this is our sample app. And if you just click on the device ID here, it gives all zeros because it's an emulator, and emulator doesn't really have an IMEI number. Okay, and let's hit OK. And I want to these are the different modules that are available. You can write your own modules. It's just a file. It's just a text file. So we'll just see what is the content of this file. So it basically hooks the Android telephony manager and returns 0007. Okay? And I submit. Okay. Let's check the device ID. Right? So I don't like the James Bond, so let's change it to something else. Okay? And do you think this is much easier than restarting your device all the time? You have to change something, right? So okay, so if you are not a fan of restarting, yes, you should try this. And it's not just changing your device ID. You can directly see the feedback right there, like if something happened or something doesn't happen or something like that. So whatever you write here, as in you can log function arguments, you can log encryption passwords and what's the data getting encrypted, etc. So we have like n number of demos planned. So it's very less slides and lots of demos. I think that's the way you like it. Okay. Okay, let's go to a different module and see what we can do over there. The hardest part is to find where is my mouse. Okay, yes. Okay, now let's look at something else called a simple root bypass. Okay, so when you are instrumenting an application, obviously the app, which if it is security sensitive, will employ some sort of root checks to make sure that you are the genuine user and not somebody who is trying to hack into the app. So root checks are very common nowadays. And how can you bypass it? You will have to reverse engineer the app, look into the methods, write a module for it, etc., right? So let's see how we can do it in like 1, 2, 3, 4 lines, I guess. Yeah. I do this. And the search continues. The phone is not rooted, but you know for a fact that emulator is rooted, right? Just to prove my point, I'll just, get the root on the device. Okay, I think I got the hang of this. Okay, yeah. Wow. Okay. Okay, so, wow, that's not there, but yeah, you can see that I am root. Okay? So I am root and the app can't really figure out if I'm root or not. So let's see what the app is trying to do and what I am doing to, make sure that this app believes that I'm running on a non-rooted device. So we'll just look at the source code of this app. Okay. This is the isPhone rooted function, which basically checks the build tags. So the build tags is basically, if you, in your emulator, if you go to the about section, you can find the build tags. So let's click on this and okay, and go here, settings. about phone. Okay, any moment now. Okay, so you can see there are like test keys written right over here, and that API would return your build tags, and all the engineering builds of AOSP, or for that matter emulators and all that, contain something called as test keys. So it basically checks if the string returned has test keys, and if it is, then yes, the device is rooted. If not, the device is not rooted. But since we are hooking this function, we can return whatever we want. We don't really look at the implementation of what is the is phone rooted doing. It's as simple as, again, it does check for the super user, which is a very common application that is installed on rooted devices to control who gets access to root, which application on your device gets access to root. So these are like generic root checks that typically you will find in an application. So basically on this button click, on this button click, it calls that particular function and displays if the phone is rooted or not rooted. And let's see how we are getting past it. So we hook the main activity, which is the main class responsible for the Android application. And then we re-implement the isPhoneRooted method. Okay? So you can see that in the code, we have a isPhoneRooted method. IsPhoneRooted method, and it returns a Boolean. It's either true or false. So here, we always return just false. So it's very less lines of code, and you just bypassed root detection, right? The state-of-the-art root detection can be bypassed in like 3 lines. So that's as easy as it gets, I guess. Okay, now let's look at some other interesting examples, and then we'll go to slides. Okay. Okay, this, right. Okay. So other checks that a typical application would do, if they are like far more advanced in root detection, is check for the presence of files. So when you root your device, there are certain files that will be left on your device, which you necessarily need not or cannot change, because it is important for those files to be present so that the root can actually work. So developers check for those files, and obviously they will use the standard Java APIs. And let's see what it does. It says the file exists. Let's actually see the implementation and figure out what is the logic behind it. Okay, so it checks for a file in the SD card, which is just a random test sample. It can be any file that you want. So it just checks if a test file exists in the SD card. And if yes, it just says that the file exists. You can make it to the SU binary in the system path, or any random application or any random file that you want to check for. Right? And now I want the function to think that the file doesn't exist. Right now the file exists. We can just verify that. Okay. Okay, here we have the test file. So that's for real. And the code checks for it. Okay, and I will just change to file reads. And in this code, I'm adding this particular file to this array. And I am just checking if the application is checking for any of these files. Okay, BusyBox, SuperUser, SU, these are the common files that are present if you root your Android device. So most of the applications might check for it. And if that's the case, it will just compare what file is being checked with what is on the list, and it returns false. Okay, so let's run this. Let's go here and let's see if the file exists now. Wow, the file doesn't exist, right? So if you notice, I'm doing like multiple things and I have never restarted my emulator. Okay? And it's just a matter of clicking, that's it. And if I want the file to be detected, I don't need to write any more code. I'll just go here, I'll just remove it from here. Now the file should exist, right? As simple as that. So it's like, you are just writing code right over here and you are getting feedback right over there. It's like it's your puppy. Right, okay. Yeah, we all like instant feedbacks, right? Okay. So you like more demos or slides? More demos? Okay, I like demos. All right. So now let's look at encryption. We all keep our data safe by using the best possible encryption, right? So obviously we should break it. Else, what are we here for? Okay. Let's break the AES encryption, which is, let's see the implementation first so that we have context of what we are breaking. Okay, it's a 128-bit, AES encryption, and the app is really secure. It encrypts using this key and with a random IV. So it's good, and it sends it to this particular function with the key as the argument and the data. And let's see what the encryption function does. It does all this magical stuff here, and it just prints out the encrypted data. Okay. Now, obviously, when we are dealing with encryption in Android apps, either we are interested in the key or we are interested in the data. Let's see in like 5 lines how we can get the key or the data. Okay. Okay. So right here, this is just the class, which is just the same. You don't have to change it at all. This is the function, and I am just re-implementing the function. The encrypt function takes 2 arguments. I just call it A and B, and I just, toString, so that I can just view it. And let's submit. Submit. Okay, and let's go backwards. Wow. Okay, yeah. And let's encrypt. Oh, seems like we have something here. Yeah, so we have the key and the data that is getting encrypted in bytes. So you just copy it to your Python program, put it there, and you get the clear text. All right? So it's right here. It's just in bytes, and this is the data that is getting encrypted, and this is the long key. Okay. Mostly because once you encrypt it, it is all non-printable characters. So that's why I should print it like this. Okay. So now that we have broken encryption, What else can we do? Okay, so Android applications have this functionality of loading native code real time and doing fancy stuff with it. It's called JNI. Anyone came across any JNI checks that they couldn't bypass? So JNI is basically you write code in C, and this C code can communicate to Java code and also do processor-intensive task. But people use it for everything because there are like standard C libraries available for almost everything, and people just reuse the code. So what if our target application is using native code? Now we have just seen all Java stuff, right? Now let's see what we can do about native code. Okay. All right. So this app doesn't do any native stuff, so I'll just resort to the Android browser. And if you're instrumenting a different app, either you can go to the first screen and just type the package name over there, or you can just type it over here. Okay, and I need to make sure that the browser is running. Okay, and I hit yes. Okay, that's there, and native hooking example, and let's submit. Okay, so yes, let's hope it works. I'm sorry? This one? ARD. Oh, wow. Typos. Yes, you have to be really careful about the typos. Thank you. And DROID. Okay. Well, that explains why it didn't work. Okay, let's kill everything because this is like taking forever to load. And let's send it again. Okay. So Android browser is like really, really slow in emulators. You get all these black codes and all that. But whenever it happens, you get the results right over there. Okay. So yeah, let's keep it there for some time. It's not a problem with our app. It's just that the browser is like extremely slow. Yeah. All right. Okay. So let's basically look at what we are doing right here. This looks different than how we did the Java stuff, right? So here we are using a Frida functionality called interceptor. We attach to libc. So libc is a standard C library that gets loaded. And then we hook all the open calls. So anybody knows what the open call does? The open call? Okay, let's go here. And this is what open does. So the first, it will have the path name of what file it is being open, what file it is trying to open, and then the flags. So if you print out the first argument, we can basically understand what the open function call, system call, is trying to open in the device, right? Wow. Okay, this is like taking forever. Okay, let's actually start the Android. Okay. All right. Okay. That's Android emulator for us. Let's. Okay, we'll get back to that demo later. So let's continue with some slides now. Play from the start. Okay. Oh yes. So let's start with the slides. All right. So yes, I am a security engineer at Intel because basically I don't get time for the demo. So I did the demo first. All right. So I've been a speaker and trainer at these conferences, and I'll be speaking at this DEF CON and Black Hat. Okay, and I am a mobile security and IoT enthusiast, and I am interested in machine learning and all that stuff. So yeah, when I'm not hacking, yes, I am filling visa applications because it's very hard for me to travel to other countries. It's a big ass form that I have to fill and wait for like 2 weeks. So that happens. And yes, this is the state-of-the-art hooking tools that are available to us right now. We can use Expose modules as I demoed. Then there is ADBI, which is like a library injection toolkit. Many awesome tools have been written on top of it. And you can use the older LD preload trick in Android as well to load your own libraries into the process. And yes, Expose framework really has a large user base and all that, but it is mostly intended for making like almost permanent changes. Like there is an Expose module for turning your Android clock into red color. I don't know why do you want to do that, but there is. So things like that. It's mostly intended for that. And what is hooking? It's about figuring out what a function does, what are the arguments it uses, or changing stuff. And how can you do hooking? You have to resort to most of these tools that are mostly available, unless you are like so awesome and you can write it by yourself. So these are the tools that we discussed. And mostly it's rebooting your device that is the most important part of the job. And yes, we did the demo of Exposed. But yeah, we actually showed you how we can do a better job of it, right? So with the program that I am presenting, you can like do dynamic instrumentation on any Android app in like 3 to 4 seconds. It's as simple as writing 4 lines of code to do what you want, rather than just going through opening up your Android emulator, you just saw how sad it is to do that. And you have to write code in Java. If it doesn't work, you have to change the code, compile it back. You have to install it again, make sure it works by rebooting the device again. So yes, if you just talk to a person who has written an Exposed module for real, they will, explain the pains of their life. Okay. So our solution should be like super fast. It should be very simple, and it should be easy to learn. It's JavaScript. It can't even get any better. So even if there is an error in the hook code that you write, you get decent stack traces. As in, it tells you that this type doesn't match, rather than the whole program crashing on you. So that's something that you want when you are trying to learn new things and explore. And it should just work. So yes, our solution is like the speediest solution that at least I have seen till date. And yeah. So it's based on Frida. It supports hooking native code and Java methods. It has a web UI, so it's just one line. You press enter, you get the awesome web UI. You just type in the name of the package that you want to instrument, hit go, select the module that you want, hit OK, and you get the results right there. So, and all these modules can be used in combination. Like, let's say that I wanted to use one of the device ID changing module with an encryption module. You can just copy the code from one of it, paste it into the other, hit submit, that's it. You get both the functionalities in one go. So yeah, it's mix and match. Now, yes, instance change to the hooking scripts. You don't need to compile anything, you just need to click the send button. I can even automate that by automatically trying it out every time you change something. But yeah, no restarts at all. Yes, we already did the demo. Yes. Okay, I have a couple more demos which deals with Android overloading. So in Java, you can like overload methods. So the complex of the libraries that you want to hook will have overloads. It's about the same method with different signatures. Let's say there is a function called a. It takes a string parameter. And there can also be a function a which takes two string parameters as the argument. So how do you hook those? So we'll just show you how to do that. Yeah. Okay. Yeah. Okay, so it's called a the first demo is a simple overload. And this is how you can hook an overload. So the dude is a method which has two signatures. And the kind of overload that you want to hook takes only one string as a parameter. The source code is like right here. Okay, so the one takes a string argument, one takes a character as an argument. So I want to hook this, okay? And let's run the code. Oh, we don't have an emulator, okay. CD. Droid. SDK. Tools. Droid, yep. We have the emulator. Start. Okay. Well, okay, we'll look into how it works and we'll have a demo whenever this starts up. Okay. So basically the overload, you give the overload a signature so that it can select which function in the overload it can hook. Then you rewrite the implementation, which is basically like this. And you log the argument, which is a, to a string. And you can call the original function. So it's very important that you call the original function once you re-implement a function, because the app might break if you don't actually, resume the functionality. Though in the implementation, we are just sending the data over here, and we are not doing anything else. So this function, this method this application will expect this function to do something. And if it doesn't, then the app might crash if it doesn't handle the exception. So this last line over here is our way of calling the actual function which the developer wrote. So this is like man in the middle. You are logging what is the argument that is being passed. You are even changing it to high, and the app doesn't know about it. The programmer, wrote the code to say bye, and you are intercepting it right over here, and you are returning hi. So this is like completely unaware. And you can do this even when the function is getting an overload or something like that. And you can have generic overloads. It's like, let's say that there are like 10 different method signatures for the function dude. You can write one single line of code which will hook everything and will return, your response to all of these overloads. So you don't need to type this 10 different times. So if the demo gods, please. Yes. Okay. So I'll just start the emulator. we should have connectivity. Okay. Yeah. Okay. Okay, this is there, and this is. Oh yes, thank you for that. I have good friends. Yeah. Okay, and we are hooking the string. So this is a normal implementation which just says yay from strings, and now it changes to hi. Like this is no dynamic code. From now on, it will just say hi. Like if you wanted to say bye, let's say, like bye. And let's submit. Okay. Any moment now. Oh yes, it changed over here. It will just take some time to update over here. Okay. Okay. Wow. Oh Lord. Okay. Let's submit it once more just to be sure. This thing is like so adamant on saying hi. It doesn't want to leave. Okay. I'll fix that. Let's see with multiple overloads. Okay. So this is the one that I talked about, which can, at the same time hook this button and also this button. So I hook, press the string one, and I get the output here, and I press the character one, and it also hooks it. So basically, what happens is all the implementations of that particular method is being hooked and is just being, called right here. And this particular method over here calls the write overload with the arguments that are passed to the actual overload method. So this particular line takes care of selecting which particular overload that you want to call with what are the arguments that are being passed. So if you are interested, we can just log the arguments right here. So this is about, you can do it here, you can do it here, and it's all logged. So multiple functions get logged just like that, with like 3 lines of code. And this is the actual. Oh, okay, time is up. 5 minutes. Let's show the implementation of the code. Okay, so as you can see, this is the first overload. This is the second overload. And I am hooking both of it just by writing 3 lines of code. So that's the demo. All right, so I will skip some of the slides. Okay. And yes. Okay, so all the source code will be here. So you can just clone it. If something doesn't work, just create an issue and I will fix it for you. And yep. So the future of this project is to add more modules so that everyone's lives gets easier. You can also contribute. You can just give me a pull request and I'll just accept it. Now supporting Frida in art, it's almost stable, but we are just working on some of the minor details, and that will be on its way. And these are some words from the actual creator of Frida. He's a good friend, and this is part of promoting Frida in the community because it's so awesome and people need to know about it. You can create your own custom tools, and it works on Windows, Linux, Mac, almost any platform that you can think of, Android, iOS. So if you learn to do stuff with Frida once, you have this functionality of dynamic analysis on all these platforms. So it's wonderful to learn. We are always active in Freenode. You can pop over and say hi. We have a mailing list as well. So we take contributions from the community in terms of documentation, apps like these, so, which makes people easier and all that. So these are some of the resources that you can look up and learn. And obviously these slides and all this code will be available. So, and I'm always available, so you can just talk. Okay, that's it. Thank you. So if you have any questions, now is a good time.
Hello.
Hello.
First, thank you for this interesting talk.
Thank you.
We saw some example of root detection, and I was wondering if DiffDroid will help, if the root detection is performed with SafetyNet, because it's really hard to bypass, because, some app may refuse to install. So at what point DiffDroid can hook it?
Okay, so SafetyNet is Google's way of ensuring that the Android Pay is secure and all that. And there is already a module out there which already bypassed it. So it's an exposed module. You can just look up the code, exposed module. Yeah.
Actually, exposed work on a root device.
Yes.
But the thing is that
if you are not already rooted, you don't have to worry about anything, right?
Yeah, if you're not rooted, you cannot install exposed.
Yes.
But if you're rooted, the app through SafetyNet will look at it.
Yeah, so exposed is a module that you install on the rooted devices, and it makes the other apps think that the device is not rooted.
Even with hide root or root cloak, as I saw that you have it.
So root cloak is not the right module to bypass SafetyNet, but there is a different module altogether in exposed that is specifically designed to bypass SafetyNet.
Oh, I'll be really interesting to have the name.
Sure.
Thank you.
We can. Because end of the day, it is the device giving the app the feedback that it is rooted. And what it can do is check the system. If you are the root, you control the system. So it's, end of the day, it's who is the better. That's it. Any other questions? Okay. Thank you so much. Thank you so much for coming.